Please title these notes Graph 7 Notes, First Derivative Equations, and write today's date. By the end of this lesson, you should be able to do graph analysis based on equations of the first derivative. Isn't that right, Drayton? Isn't that the most important thing you could possibly be learning right now? Yes, you're going to come up and help learn it now, aren't you? Yes, yes. Aren't you adorable? Aren't you adorable? Okay, let's come back to the notes. So what we're doing first is we're going to compare how graph analysis, so graph analysis is just the name for finding relative minima, finding inflection points, finding increasing, decreasing, all that kind of thing. How graph analysis works with graphs, which we've already done, to how it works when you have an equation instead of a graph. And now theoretically you could just, graph the equation, but in the olden days they didn't have graphing calculators that would do that, and besides it takes way longer than the methods that we have for calculus. So these are actually the same problem, they're just written out two different ways. Given the graph for f prime of x, that's this right here, f prime of x, at what value of x does f of x have a relative maximum? And here given the equation, so that was the graph, this is the equation over here, f of x equals x cubed over 3 minus 4x plus 2, at what value of x does f of x have a relative maximum? So I'm going to write each step. The steps that are the same for both, I'm going to write all the way across. The steps that are unique to one, I'm going to keep right over here. So the first step using the f double prime, f table, draw and label your answer line. So we want to know where f of x has a relative maximum, so that's increasing, decreasing, and that's it. So for graphs, we know that in the past we were just identifying if you're given the graph of f double prime, f prime, or f, draw and label the translation line for that function. So in this particular case, we know that we want to ultimately have f of x increasing, decreasing. So that translates, we're given f prime of x, that translates to plus or minus. What's different about the equations, we're still going to end up in the same place, but we're going to come by it at a different route. We're always going to draw a plus minus line for the translation line. Use the f double prime, f chart to label the function. So what this looks like is we know that we want to have an increasing, decreasing function for f of x. So regardless, because we actually don't have anything else given aside from the f of x up there, I am going to do a plus minus line. Always. Every single time we do an equation, it is a plus minus line. The reason for that is it's fairly easy to figure out where an equation is positive or negative. Figuring out where an equation itself is increasing, decreasing, we can't just look at a graph. It's very difficult to do. So this will always be plus minus. Then I come over here. I say f of x is increasing, decreasing, plus minus. That's f prime. So I'm going to label this f prime of x. Notice that these two end up looking the same, but we came to them by different routes. Here, this part got labeled first, and then we translated to get that. Here, the plus minus is labeled first, we translate to get that. Our third step for the graphs was to fill in the translation line from the graph given. So in that case, this was f prime of x, that's given to us up here, positive up to negative 2, negative until 2, and then positive the rest of the way. So just filled that in from the graph there. For equations, we're going to actually have to do a couple more steps. The first thing we do is take derivatives. Until we get the function on the translation line. So just for clarity's sake, this is the translation. This is the answer. So we are looking for f prime of x. We start with f of x. Take the derivative. So that's 3x squared over 3 minus 4. Okay, that actually looks about like what that. It's an x squared graph opening up. That should be right. And then now, there's a 3.5 step here. Use the equation to make a sign chart on the plus minus translation line. So this is why we had to do a plus minus line, because that's what we know how to do with the sign charts. So we've got this f prime of x this can be factored. X plus 2 equals 0, x equals negative 2. X minus 2 equals 0, x equals positive 2. And if we put in a number less than 2, so negative 3, then we get negative 3 plus 2, negative 2 minus 2, that's a negative, so it's a positive overall. A number between negative 2 and 2, so that would be something like 0. Actually, I'm going to do it in this color so it's clearer. 0 plus 2, 0 minus 2, that's a plus, that's a minus. So negative overall. And then finally a number bigger than 2, let's say 3. 3 plus 2, 3 minus 2, that's a positive, that's positive. Same thing on this chart that we had over there. For our fourth step, things are going to go back to being the same. Translate and fill in the answer line. So here we've got our f prime of x that we got either way. This was plus minus. Now our answer line, if you remember from the beginning, was f of x, and f of x was increasing, decreasing. So we translate, and then last of all, answer the question. There is a relative maximum for f of x at x equals -2 because f prime of x changes from positive to negative. So f of x changes from increasing to decreasing. And there we go. Let's do some practice problems. If f of x equals 1/3 x cubed minus 1/2, that's a cubed, minus 1/2 x squared minus 6x. For starters, at what value of x does f of x, notice, f of x, have a relative minimum? So we're going to start out, we're interested in f of x. Minimum is the increasing, decreasing line. Now because we have an equation, we're going to have a plus minus for our translation line. Increasing, decreasing in f of x translates into plus minus in f prime. So now, because we're working with f prime of x, that means we need to get f prime. So let's start off with this. We've got f of x equals 1/3 x cubed minus 1/2 x squared minus 6x. F prime of x, 1/3 times 3x squared minus 1/2, oop, that got away, times 2x minus 6. Those cancel out. Now we can factor that. And find our zeros. Now notice we're dealing with f primes. That means I'm going to put this on the f prime graph. -2 and 3. And now I'm just doing the same thing that I've always done, except you can make it a little faster. You don't have to write out all the steps. You can just do little plus minuses if you like. A number smaller than -2, -3. -3 minus 3 is negative. -3 plus 2 is negative. Two negatives make a positive. And to put little parentheses if you want to keep it clear. 0 minus 3 is a negative. 0 plus 2 is a positive. Negative overall. Greater than 3, that'd be like 4 or something. 4 minus 3 is positive. 4 plus 2 is positive. Positive overall. So now I'm going to translate this, just like we've done before. F of x has a relative minimum at x equals 3, notice that right there, because f prime of x changes from negative to positive. So f of x changes from decreasing to increasing. We can also ask a question like this. On what intervals is f of x increasing? Well, we already have our f of x line from right here, so we can just redraw that. F of x is increasing when x is less than -2 or x is greater than 3, because f prime is positive. Let's do a check for understanding problem. This one's already been factored. For what values of x does f of x have a relative maximum? First thing, we draw our answer line. Second thing, because we're working with an equation, we translate it to plus minus, and that happens to be f prime of x. And look, lo and behold, we already have an f prime of x. So f prime of x is 2e to the x, x plus 3. So we find our zeros and make our sign chart. 2e to the x never equals 0, that's always positive. So for a number less than -3, 2e to the whatever is always positive. A number less than like -4, -4 plus 3 is going to be negative, so this is negative overall. A number greater than -3, so let's say 0, 2 times e to the 0 power, well, this is always positive. And 0 plus 3, that's going to be positive as well, positive overall. Now we translate, we know this is -3. Negative translates to decreasing, positive translates to increasing. For what values of f of x does f of x have a relative maximum? None. F of x never changes from increasing to decreasing. Because f prime of x never changes from positive to negative. Now, if it asked for a relative minimum would be at -3. But in this case, there's no relative maximum. That happens sometimes. There are some other things that can be asked for. Critical values or critical points mean all values for x that might potentially be relative minima or maxima. This means all values of x where f prime of x is 0 or undefined. We can also ask for relative extremas, particularly all relative extrema. Relative extrema. Means both relative minima and relative maxima. We can be asked for a local minimum, maximum, which is the same as a relative minimum or maximum. And we can be asked for what is the value of the relative minimum or maximum. This means find the y coordinate, which we can do with equations much more easily than we can do with graphs. And on a related note, we can be asked to find the coordinates of the relative minimum or maximum, which means find the x, y coordinate point. These are all asking for about the same thing. It's the same general idea, just different vocabulary that you'll see sometimes. So let's do a couple of practice problems and check for understanding on these. Find the value of the local minimum of f of x equals x to the fourth over 4 minus x cubed. So a couple of translation things. Value, that means y coordinate, or y value. Of the local, this means relative minimum. So, as always, we're going to start off. We want f of x. We want a relative minimum, so that's the increasing, decreasing line. We're doing an equation, so this has to be plus minus. This translates to f prime of x. We want to fill in f prime of x, so we need to have f prime. So we take the derivative of this. This is 4x to the third over 4 minus 3x squared. That cancels out. We can factor out an x squared. Do our zeros. Fill those in. Okay, a number less than 0, this is squared, I don't care. Negative 1 minus 3 is going to be negative, so this is negative. A number between 0 and 3, this is squared, I don't care. 1 minus 3 is still negative, so that's also negative. And a number bigger than 3, this is squared, don't care. 4 minus 3, that would also be positive. So, there's our sign chart for f prime of x. Now we can translate this. Negative is decreasing, negative is decreasing, positive is increasing. And now we got this nice little minimum right here. However, this is where it's really important to read the question. We don't want the relative minimum value, relative minimum x. value. We want the relative minimum y value. So let's go remind ourselves. Find the y value. That's easy enough. We just want to find f of 3. That's all it's asking for. Remember, we're doing the f of the relative minimum value of f of x, so we're working with this. Just plug 3 in right here. We've got 81/4 minus 27. Want to get a common denominator. And there we go. We found our value. Okay, for problem number 4, find the critical values of f of x equals x squared plus 1 over x. Remember, critical values mean f prime of x equals 0 or undefined. So we actually don't even need our little translation charts here. This is the one time we don't need translation charts. So we just need to find where f prime equals 0 undefined. So first we need f prime. This is definitely going to be the quotient rule, derivative of x squared plus 1 times x minus x squared plus 1, derivative of x, all over the denominator squared. Derivative of x squared plus 1 is 2x. Derivative of x is 1. So we have 2x squared minus x squared minus 1 all over x squared. So that's x squared minus 1 over x squared. Now we need to figure out where this is going to either equal 0, so the numerator equals 0, so x squared minus 1 equals 0. Add 1 to both sides. Take plus or minus the square root of both sides. You could also have done this by factoring. That works just as well. F prime of x equals undefined if the denominator is 0. So the critical values are x equals 1, x equals negative 1, and 0. Okay, for our final problem, let's make it a check for understanding. So, if f of x equals x times e to the x, find the coordinates of the relative minimum of f of x. Notice coordinates, we want x and y. Go ahead and pause the video and try this one on your own, and then come back and I'll show you the answer. key thing here, again, this is x comma y. Okay, relative minimum of f of x. Minimum is increasing, decreasing. We are using equations, so that means we've got a plus minus line, and the translation is f prime. So we're going to be working with f prime, so that means we need an f prime equation. So start with f of x equals x times e to the x. Okay, take the derivative. Product rule, derivative of x times e to the x plus x times the derivative of e to the x. Derivative of x is 1. Derivative of e to the x is e to the x. Now remember, for sign charts, first we factor if we can. Okay, now we can find zeros. That never happens. Okay, so up here, -1, that's the only value that's interesting. So we're going to pick a number less than -1. This is always positive, so it doesn't matter. A number less than -1, let's say -2. 1 minus 2 is negative, so this is negative overall. A number bigger than -1, let's call it 0. This first factor is always positive, doesn't matter. 1 plus 0 would be positive, so positive overall. So translating that over here, that means we have a relative minimum at x equals -1. However, we want the coordinates. So x equals -1 at relative minimum. What's f of -1? Well, we can just plug it in right there. E, just leave e as e, but a negative exponent means it goes in the denominator, so we have -1 over e. So that means the coordinates of the relative minimum are -1, comma, -1 over e. That concludes these notes.